talking about object-oriented programming and TypeScript. Can you all see my screen? Yeah. So I understand that actually this Monday you did a little bit of object-oriented programming as well, right?
Yeah, we got an intro to it.
Yeah. How did you find that? Did you understand what you talked about and stuff? Does it make sense?
Yeah, kind of. That's yeah.
What do you think, Christina?
No, I think I don't understand.
You don't understand. What do you think, Julio? Julio?
Yeah, I think it makes sense. I think it's.
Yeah.
I think it's the more you sort of look at it, the more you sort of understand it. I think at first it can be a bit more complicated, but.
What do you think, Ricardo? I think, Ricardo, you have some experience from different language, right?
Yeah, and I'm familiar with object-oriented. Obviously, for first-timers, like the first time you get there, it's like crazy, hard to get. So I understand like the confusion. But yeah, I'm very familiar with it.
Cool. Great.
One of the things, I mean, I'm surprised, to be honest, in the course. I feel that we've covered really a lot during all these months. And for example, something like SAS and preprocessors, I was not expecting to cover that. So like I said, I'm not a front-end person. As a general knowledge, it's very good that you guys offer that as part of the program. And I wasn't expecting TypeScript either, which I like very much because I was used to the very, very old syntax of JavaScript. Now I'm having a lot of fun with the new way of working with functions. But before that, it was like TypeScript is what makes sense, like make you feel like this is a real programming now that you work with TypeScript. So I'm surprised that you have that in the program as well. Let's get on it. It's really cool.
Yeah, I mean, TypeScript is... So let's just talk about it very quickly. So TypeScript is basically something that, and I will just give you like a high level and then we will dig into it a little bit more. TypeScript is exactly what Ricardo said. They developed it mainly for the kind of familiarity that it brings into JavaScript, right? Because JavaScript is a little bit of a wild west in languages, if you think about it that way, because of the asynchronous code, because of the dynamic types and all this kind of stuff. JavaScript is very much not following a lot of things that you would have to follow in different language, right? And garbage collection, for example, as well. So when you have different, obviously there is this big movement where it kind of, the perception is that that developers just need to understand everything, right? So you will have a lot of front-end developers who will be moving to full stack because they want to understand the backend as well, while you will have a lot of backend developers who will be kind of trying to get their hands on the front end because, like a new doors open, because again, they could claim that they are full stack and stuff like that. So TypeScript, one of the reasons why it was created was to bring this familiarity. So if you have a guy who is working in Java, for example, which is very similar to TypeScript, if you work in Java, he would have quite hard time to start working in JavaScript. But with TypeScript is a bit more familiar, and he can basically use that to write JavaScript. Now, there are good things and bad things about it. The good thing about it, obviously, is that it gets you up to speed very quickly. The bad thing about it is that TypeScript, on purpose, will kind of disable some things of JavaScript. And when I say disable, I don't mean that it like physically disables them, but it kind of guides you in the way not to write it that way, to actually write it in the way that you would write it in different languages, which is, some JavaScript is the way it is for a reason, right? So that it was designed like that for very particular scenarios. So in some scenarios you would just not want to use TypeScript. You would actually want to use JavaScript because it has all the things that you don't need from the strongly typed languages or other languages. The good thing though, and I think that's so TypeScript is created by Microsoft. I don't know if you are aware. So what Microsoft did well with TypeScript is that any JavaScript code is a valid TypeScript code. Okay, so when you write your TypeScript, if you write inside of your TypeScript any kind of JavaScript, just a plain JavaScript, it will work. It's not gonna break. So that way, it's quite nice because you can still use some things of JavaScript that you normally wouldn't use in TypeScript. That being said, you shouldn't do that, right? Because then you're mixing two worlds together, and you kind of, yeah, it's not gonna work that well together. So yeah, but they still give you the option. So let's start. Let's start with a little. Let's continue with the object-oriented programming first, and then we will dive more into TypeScript. So let's see what we have in these slides. So I'm so sorry, but these slides are a little bit outdated. So I'm just gonna be basically reading through them, and if I will be telling you probably something else, but let's just go through them. So object-oriented programming. JavaScript is not a object-oriented language. That is very much true. No matter if you use JavaScript classes or if you use TypeScript, the bottom line is it is not an object-oriented programming. So in a sense where if you use the object-oriented programming in JavaScript that is built in with ES6 or TypeScript, still like under the hood, it's still just functions and objects, right? Like JavaScript is not a true object-oriented programming. Language. Some object-oriented rules can be applied. So again, either TypeScript or ES6, and I will explain the difference soon. You can use that. So you can use classes, you can use inheritance, you can use extend classes and stuff like that. They kind of simulate that, right? So they will let you use it just because people like to use it, but it's not like it's not actually true object-oriented, but you can use it. Creative ways were used. Yeah, as I said, they try to kind of simulate the object-orientedness. And then TypeScript was invented. So TypeScript was actually invented. So before we had classes in the pure JavaScript, people tried to mimic whatever object-oriented programming they thought was by different ways. So you can use closures and other stuff, and currying and other things. So people tried to mimic that, and then TypeScript came along and try to solve this problem. Among others, there are other problems that TypeScript will solve, and I will show you that in a second. So TypeScript was kind of developed, I would say, before the ES6, which is the kind of newest version of JavaScript, let's say, was actually released into production, into all the browsers, when it was supported. So TypeScript kind of tried to bring everything that the new JavaScript will bring, but earlier. TypeScript. So TypeScript is a superset of JavaScript. What we mean by superset means what I told you a minute ago. You can just write a pure JavaScript into a TypeScript and it will work, but TypeScript has some extra stuff basically, so some extra sauce on top of that. So that's what we mean by superset. TypeScript is not a valid JavaScript, but JavaScript is a valid TypeScript, right? So if you want to write JavaScript into TypeScript, all is fine. If you want to write TypeScript, you need to first compile it to be just pure JavaScript before you can use it. You cannot just, for example, you can just take a piece of TypeScript and run it in your browser. It's not going to run because that's not a valid JavaScript, right? TypeScript is strongly typed. This should be edited a little bit because it can be strongly typed. Does anyone know what strongly typed means?
I don't know. It's basically that it requires you to specifically detail the types when you're dealing with. Like, for example, in a different language, if you're going to have an age, that must be an integer. If you're going to use a currency, for example, it must be a double, but you need to specify the type of that variable. For strongly typed languages, because if you don't, then they won't compile because they will send you an error. So if they are not strongly typed, probably you just declare the variable and do not specify the type, and it will still work. But when it's strongly typed, you have to define the type whenever you define the element, in this case, like the variable or the constant.
Yes, so thank you for that, Ricardo. He pretty much said it all. What it really means is that you need to specify types for your variables. But when I say variables, it's not necessarily just variables, it's also functions. So if you create a function, you specify what type that function returns. If you create a instance of a class, you need to specify that what class is it instance of, and so on and so on. So basically what it means, and when we say variable, it doesn't necessarily mean when you're just declaring variable. It also means function parameters and all these kind of things. So what it basically means, imagine that you have a function, and let me just go into a code for a second. So imagine that you have a function. Oh, what's this? Right, so normal function as we would normally have. So hello world. Can you see it fine, or should I make it bigger? I guess everybody knows.
Looks like we.
Cool. All right, so this would be our normal function, let's say, yeah, like a normal usual function. Now this is a JavaScript, and this is perfectly fine in JavaScript, but in TypeScript or strong type, not necessarily TypeScript, but strong type languages, you couldn't actually have this, right? Because the compiler would then complain that it doesn't know what these variables are and what the function will return. So what you really need to do in strong type languages, you need to tell the language that I am using a parameter of name, and the parameter will be some kind of type. So you would say, for example, it will be string. Okay, and then you would also say that this function will return a string, right? So you would say this function will return a string. Okay, so then in that case, you would know when you use it. Then you could use it like this, hello world, and you could say let's say you would say true, right? You can see, because I named it as a TypeScript already, you can see that it's already giving me an error. And if you look at it, it will say argument type of Boolean is not assignable to parameter of type string. So that's exactly what these strong type languages do. They will not let you to use this function with anything else than a string as a parameter. Okay, and the same way, you can be sure what this function will return, that it will return string, because we specify at the beginning that this function is going to return string. So if you try to return anything else in the function, it will show you an error. It will say this function needs to return a string. So this is basically the example of strong type language. Now, why is it good? Why could it be good? Well, let's say that you have a big project, right? Like really big project, and you're using also lots of functions and lots of variables. Then it can be very kind of like safe for you to have typed language, because you know exactly what some functions or what some variables expect as a type or are as a type. So in that case, if I create a function like this in here, and then somewhere down the line I will have a title with file with greetings.ts, let's say. So imagine that this greetings.ts has been added a year later, and it's like, you know, somewhere down in the tree, and you don't even know what this index where it is. So now if you use the function from there, from hello world, right, you will know exactly. It will tell you, look, it will tell you you need to use name, and it will be a string, and it will return a string. Yeah. So then you can, if I put true in here, it will again even though it's across the files, it will tell me that I'm using something wrong. So I can just say, you know, string. Oh, sorry, string. Come on. Right? And now everything is okay. If I want to assign the value to something, so if I would say, you know, greeting, yeah. So now if I say, I forgot how to write it. Yeah. So now look, if I write it like this, it says the number. It will tell me that I haven't written TypeScript for a long time, by the way. So sorry. Like this. Right. Let's have a look at it later. Oh no, actually, it's gonna be like this, isn't it? Right. We will check that later on the documentation. But basically, you will have to specify what this is. What variable? What type is this? And if you specify the wrong type, you will see this kind of underline again. Just do like this. So that's the kind of advantage of strongly typed language, that you know what the types are for all your functions and stuff. So then you can't really make a mistake, let's say, by calling a function with a parameter that wouldn't make sense, if you say that way. Obviously, from JavaScript, we are used to using a dynamically typed language, what it's called. So if I just create a index, if I just create a new JavaScript file, we can do something like this. So we can do just function hello world name, and then this will work as well, exactly the same way. Only we can never be sure what this parameter should be, right? So we don't know if this is going to be a string. If I call it the same way like I called the other one, and I will say true, then I will not get any highlight. It will not tell me that something is wrong, because it doesn't know that something is wrong, because we didn't specify that this should be some kind of type. It can be any. You can even see it in here. It will tell you that the name is type of any. So that means it can be any type you want. So this is kind of good and bad in JavaScript, but for the same reason that for what TypeScript is good. Good because sometimes you just want to have a little bit more flexibility in your functions and in your variables. Everybody looks at it a little bit
correctly. In JavaScript, you can also specify what you want, right? So if you put function hello world name equals boolean, or
no, you can't do that, unfortunately. So
you can.
So that's why we can't do that.
Is this? Oh no! So it's like if you want to say force a value like equals 0 equals an array.
Oh, you can do default value. Yes, you can do. So you can do something like this. You can. Yeah. Oh, sorry.
Yeah, like the actual exactly. Yeah.
Yeah, you can do this. But again, this is something that was not in JavaScript before TypeScript came around, right? So TypeScript introduced this, but since then JavaScript has moved on, and they added it as well. So
okay. So
yeah.
the ES6. Okay.
Yeah, exactly. So TypeScript is always kind of a step ahead with implementing a new things that they think is very they are good, or things that might not even come to JavaScript, but eventually JavaScript will catch up. The way that TypeScript and what they actually put into that language is they will look at the new specifications of JavaScript, the specifications that are drafted but not implemented by browsers yet, and they will kind of implement it themselves in TypeScript. So they will enable you to use it even before it's actually released to the browsers, which is, in some ways it's quite nice, because then eventually when the JavaScript catches up, then you just change your extension on the file. That's theoretically, but it could work that way. Yeah, so that's strongly typed versus dynamically typed. Does anybody have any question about that?
I'm just curious. I mean, I guess it's maybe a topic for later, but why would Microsoft be involved in that? I mean, another question. Sorry.
Well, so the Microsoft actually, as far as I remember, well, at least at the beginning, I used TypeScript when the first version was released, and at that time it was kind of cooperation between Google and Microsoft, and it was literally, I think it was just the kind of publicity for them, I would say, because obviously the JavaScript world is growing so fast, and I think they just wanted to be the ones who bring something really good to the table, basically. The other reason for that could be, and this is just my kind of thinking, is because a lot of new projects from Microsoft are written in JavaScript. So even this, right? Even your Visual Studio is written in JavaScript. It's a JavaScript application. It's incredible, but it is. The same way, if you work with Excel or any kind of Office suite, if you wanted to create an extension for or add-on for Excel or Docs or something like that, it used to be in .NET, but they actually now, the newer versions, and I say now, but like let's say last 3 or so years, you can write add-ons in JavaScript. So you can write native add-ons for Excel and other Office suite programs in JavaScript because they have JavaScript API of them. And they also have JavaScript implementation on the web, right? So you can use now, you don't even have to install Office now, you can just use their online tools, and they are all written in JavaScript. So they heavily invested in JavaScript. So I think that's probably why they created TypeScript as well. And I'm pretty sure that all these applications that I just mentioned, they are probably written in TypeScript because they, they just like to use their own tools. Yeah.
Interesting. Okay.
But you are quite right. When TypeScript came out, everybody was like, "Whoa, why is Microsoft doing this?" It was quite a big thing. It's the same like when Microsoft bought GitHub. Everybody was kind of going crazy about it. Why is Microsoft buying GitHub? And then additional features on top of strong types. So yes, so this is quite important. TypeScript is it's always regarded as a strongly typed language that is basically JavaScript, but TypeScript has a lot more functionality than just the types. TypeScript will actually, and this is one thing that I don't like about TypeScript personally, TypeScript will actually fix your code as well. So for example, if you do something that you shouldn't be doing, like if I say, if I just quickly do this, right? So if I say function, oh no, let's do this even simpler. So if I create a loop, and in the loop I will do set timeout, so this what you see in here is an anti-pattern for JavaScript, right? Because what we're doing is we are doing synchronous loop, so we will looping 10 times, but inside of the synchronous loop we are doing something asynchronous. So basically this console log is going to happen outside of the scope of this loop because it will happen sometime in the future. Okay. Now you wouldn't see any difference. The way that I wrote it in here, you wouldn't see any difference in the actual program because everything is spaced out 2 seconds basically. But if you imagine that this would be a random number, or if it would be some kind of instruction, some kind of command that takes X amount of time depending on what's inside of it, then you could get some results before the others. So you would expect to go the results from 0 to 10, but sometimes you could get 0, 3, 5, and so on and so on and so on. So, well, at least when I was using TypeScript, and I think it's still going to be like that, TypeScript will actually fix this for you. So if you make something asynchronous in a loop, they will fix it and write it in the way that it actually should be written. And we will try that in a second because I'm interested if they actually still do it. So these kind of things is something in TypeScript that I don't necessarily like personally, because obviously we should be writing code that we know what it's doing, and it's actually good code rather than relying on TypeScript to fix it for you. The other things that TypeScript does, TypeScript will let you compile. So TypeScript, right, as these kind of things, they will compile into a vanilla JavaScript. They will compile into a pure JavaScript. When the compilation happens, there is a config file on the TypeScript side that you can configure as much as you want. And what it does is you can change the target for your compilation. And by target, what I mean is you can change the version of JavaScript that you want to compile it to. So for example, if you're writing an application that should work on Internet Explorer, then you might say, okay, I want to compile this into an ES file, in ES5 kind of JavaScript. If you don't worry about the compatibility and you just want like the best code basically out there, then you would compile it into ES6 and so on. They have different different targets that you can compile it into. So it is pretty good tool in that sense, where if you imagine that you have a program that is written in TypeScript, it works fine. You can be, I would say, 99% sure that if you compile it into different target, it will work as well. So for example, if you work, and this is actually the example that I was working with when I was working with TypeScript, we wrote an application where we had still quite a few, it was finance, so quite a few people running Windows XP and Internet Explorer. So we had to compile everything into all JavaScript. And we wrote everything in TypeScript, and we just set the target to all JavaScript. Once we were kind of, once we knew that most of our customers would convert into better systems or started using Chrome or something like that, and we gave them enough time, then we just simply changed the target to a new JavaScript, and we compiled the application. It was just working. It was much nicer code in the end, and it was a little bit faster as well and stuff. So that's good as well, that you can, because it's compiling your code, you can configure it. You can configure the compilation to do stuff, right? You can do prefixes and some other stuff that you can do, but the target, I would say, is the most important. Does that make any sense?
Yeah.
Yeah. What do we have next? Why TypeScript? So computers are good at catching errors. Yeah. So if you, I guess Ricardo has more experience with this than others, but if you have a compiled language, they will basically tell you what's wrong with your code in the syntax. What's wrong with your syntax, right? So if the compiler will look at your code, it will try to compile it into a machine code, and it will tell you exactly what lines and what errors you have in your programs. JavaScript, it doesn't do it that much, right? Because JavaScript, because it's dynamically typed and because of other things, it cannot catch every single error. It cannot tell you that your memory is leaking, for example. So that's why computers are good at catching errors. So that's why adding a compiler as a kind of TypeScript compiler will give you more kind of options. It will, as you type your code, it will show you the errors that there might be with your code. Refactoring is a big cause of bugs. Yeah. Object-oriented makes sense. This is kind of this is this kind of point where you really need to decide with your own project. Does it make sense? For some projects it does, especially for projects where you deal with data. So if you imagine on the backend, you can, by the way, you can use TypeScript on the backend as well. You can use TypeScript in JavaScript on the front end or in the backend. It doesn't matter. It's just JavaScript. So for example, if you on your backend, let's say if you're dealing with data in a sense where you're saving into database and so on, then it would make sense to use object-oriented programming, because you will have, let's say, if you have a library, you want to create a class of book, and you want to basically create new instances of book and so on. So object-oriented programming makes sense in some cases, not in every case, but in some cases it does. And as I said, JavaScript is a valid TypeScript, so you can write JavaScript file into TypeScript. Yeah. So now refactoring. So this is basically showing. Right. So this is already showing one kind of example of what TypeScript is good at. So if you look at the first function, or on the first slide, we have a new function that's called say hello. It takes a user and it prints out hello user. Okay? So that's pretty much what we did there anyway. And it says say hello sum. So this will be fine. Then you start working on it a little bit more, and you want to connect to an API where you get the user. Right? So you have the same function. You don't want to change your functions. That's why creating a pure functions is very useful, because you don't have to change them that often. And then you load the user from the API, and then you pass the user into your function, and you're expecting the same result. But instead, this is basically your result, right? So you will get hello object. What this tells you is that instead of a simple value, simple string of the name of the user, you are actually getting a whole object of user. Okay, so now you can already see that in JavaScript, in like a dynamically typed language, you would get this error because you are getting object and you're passing it into a function that is expecting a string. So now this is what you can do in TypeScript. You can say that the user is going to be a string, and it will return this. And then when you use it with your API, you would pass it in, and it would basically scream at you, can't use an object, you need to pass a string. That will be your compiler error. And so it's kind of helping you with the types. So then you would fix it, and you would say, okay, actually I need to pass in just user.name, and it would be hello sum. Right, and this is slightly different thing, so we're gonna get to it. Does it make sense up until now? Anyone?
Yeah, it does.
Yeah, cool. Yeah, okay. So let's have a look at, so if you look at the TypeScript website, right, so this is the TypeScript website. I will encourage you to all go and check out the website. They have pretty good documentation and everything. They have their playground. So basically, you don't even have to install it. I was told by Vassal that you're not going to be actually using TypeScript in your exercises, so you don't have to install it if you don't want to. You can just try it in the browser. So try it in your browser. And again, what I told you before, you can see this online thing, this online editor that they have in here looks very familiar, and it is because it's actually VS Code. Right? On the background, this is actually your VS Code running in the browser, and that's one thing that I think Microsoft had done very well by writing these applications in JavaScript, and they would write them in some other languages or whatever. So now basically you can take the whole Visual Studio, they open sourced it as well. You can take the open source of this editor and you can use it on your website, and you will have a full-blown code editor on your website, which is really cool. So on their website, you will see, let's go to docs first. So you will see a documentation, and in here you can get basically everything that you need. This is the most used things basically. And the types and stuff. Yeah, and you can go and basically just read everything about it. They even have some guides for programmers coming from different languages, which is really nice. That was not here before. It was really cool. Let's see for the JavaScript programmers like you. So I did write it correctly before. That's interesting. Yeah, so in here you can actually see some kind of guide of how to write all these types and all the other stuff. And in the, let's go to the playground again. All right, so let's execute what we had actually in our in that example. So we will have a function that says hello, and it will take a user, and it will return hello. So here we go. Now if we call, so what you will see in here on the right hand side is already the compiling basically. So you will see in here on the right hand side, you will see what is actually happening. So let's do this again. So now we do say hello and Thomas, for example. Yeah. We run. Oh, logs. Okay, so console log. Very cool. This playground. You will have logs, and you will also see what the compiled application is. So on the left hand side, this is our TypeScript. This is our TypeScript file. On the right hand side is what you will get from the compiler. So when it actually compiles this code, it will look like this in JavaScript. Okay. So right now you can see that it looks exactly the same as what we wrote in here, because this at the moment this is just JavaScript. There's nothing special about this, and this is compiled. Now to fix this problem, which they will tell you that parameter user is implicitly has any type, which means any type is something we will talk about in a second, but it basically means it can be anything, same as in JavaScript. So now we will say that this is actually a string. Yeah. So now the error went away. If we try to put something else than a string in there, it will give you an error. If you look at the errors in here, it will say argument.type of number is not assignable to type of string. So that's expected because we have number and we want string. In the logs, you will still have hello 1, 2, 3 because it still executes. It's still JavaScript. And it compiles into this, which is still what we saw before. You see that there is no mention of this string thing. Yeah.
And if you use VS Code, you don't get this error message. It's just this playground.
Yeah, you do as well. You get it as well. So so VS Code by default, actually I didn't install TypeScript even in here yet. By default, it will give you these kind of errors. So let's go back in here then and let's see. So we will have function hello world.
So if you remove the name string, for example, it will tell you
yep.
How.
So now if I remove this, you will see that we have these 3 dots in here, and you can see it says exactly the same thing like on the
cool.
thing. So this actually seems like this actually has TypeScript compiler built in the VS Code, which again kind of proves what I was thinking, that it's written in TypeScript basically. So yeah, so it gives you all these kind of errors. If I try and call it, so actually let's change this just to go with the slides. So if I call this and I call it with something else, so yeah, so I call it for example with array 1, 2, 3, then it should then it will give me an error, and it will say that this actually has to be a string, right? And you can already see it's kind of giving you the answers how you should write it if you want to write it correctly. So if you want a list of numbers instead of a name, then you would write it like this, the type. And so instead of that, you would write number. You want it to be a number, and you want it to be a list of numbers, so you would write it like this. Okay. So yeah, so you get this kind of highlighting in here as well, which is very nice. Yeah, so here we are. So now let's, as we did there with the API, we had something like this. So we had name. Someone. Oh, actually, let's just put it in here. For example, this, and then we will pass it in. So API result. Right, so you can see again it compiled because it's just JavaScript, so it will compile anyway. And it will give us an error that this cannot be in because argument type of, this is the type, isn't assignable to parameter of string. In errors, you will see the same error, and in logs, if you run it, you will see hello object like you saw in the slide. So this is already, this third log that you see in here is already like basically a bug in your application, right? This cannot happen, and it happens quite often actually. So to prevent that, one of the ways would be you can use Typescript, and you can tell exactly what types are going into functions. Now moving on to what is then next. So what could you do next? Imagine that this object that we're passing in, we are kind of relying on that it's going to have a name in it. If I change this to first name and run it, you will have API result name. Right, so we're relying on that's going to be there. We will have hello undefined because obviously there is no .name, there's no name key in this object, the API result. So you can prevent that as well. You can basically create your own types in Typescript. What I mean by that is, if you want to make sure that you're passing some kind of structure of an object into a function, or if you're basically working with that kind of structure on an object, you can create your own type, which is called an interface, and you can specify what it should look like. So if we do it in here, you can see I can create a new interface. So I would say interface, and I would say user API result, for example. So this is my interface. And I would say, okay, in my interface, I will have first name, which will be a string, and I will have surname, which will be a string, and I will have age, which will be number, for example. So now I created a new interface, right? So this is basically now a type. Okay. Now, if I assign this type, this interface, to my API result, so, and I think it should be like this. I don't know why it didn't work before, but user API result, right? So now basically what you can't see this, can you? Is that better? So now basically what I set in here is that this variable will be the type of this, and this type is our custom created interface. Okay, so we can go up here and we can see this is first name, surname, age. Why is it highlighted red? If you look at errors, it will say property age is missing in type this type, which is required by user API result. So it will actually even tell you, if you're creating your objects in the application, it will even tell you that you're missing something from your objects. Right? So if I add age now in here, then it will disappear, right? So you're not gonna have error anymore in here. Okay.
But so interface, just to make sure I understand, is this how does it compare to the regular objects in JavaScript that we learn? Is it just the fact that it is a bit more kind of telling you, oh, you missed the age, or
So good question. It's not actually an object in JavaScript. So interface is 100% TypeScript thing. Look at the compiled code. You will see that there is nothing mentioned about the interface, because interface is not a valid JavaScript code. It's just something that TypeScript implements. It looks like an object, but it's not actually an object. Don't forget that curly brackets in JavaScript just mean opening and closing of a block. It doesn't necessarily mean it's an object. So you're creating interface and you're describing what's inside of the interface, and then you're creating the object that is based on this interface.
So is it kind of a blueprint, this interface?
Yes, exactly. So it basically is more kind of more complex type, let's say. So it's almost like you're creating one type, but it's made out of a lot of small types, let's say. And you can have them
because if you have like a big application, you want to very custom.
Yeah, exactly. If you have big application, that's what you want to do. Especially again, if you work with tables and stuff like that. So you could even have like user table, and you could say every user has an ID. Actually, let me just. User table, and every table has an ID, which is a number, and it would have a again first name, which is string, last name, which is string, and age, number, and sex and number. String. Right. So you could have something like this. So then, when you have your interface as a user table for your table in database, then you can know exactly what to expect. So when you read something from the table, you know exactly what you will get there, and you can also create new objects based on this interface, just to make sure that you have all the information that you need. The interface it's a kind of chapter on its own. You can do a lot of stuff in there. You can group them as well. So as I have the user API result, I could say instead of saying that it will have all this, I could say that it has user, which is the type of user table, right? So now I know, and then I could say like it will have status, for example, which is number. So now basically what I did is I created one interface, and then I created another interface with an object in it, or with a kind of thing in it that is the type of user table. So now I know that my user API result will have user in it, and everything inside of the user is described in here. So I know exactly what is going to be inside of the user.
So if I understand correctly the course of Monday, this is a superclass, the second bit?
It's not a classes, but it is something like that. Yeah, you're not extending anything. This is interface is kind of standalone thing. It's not class, but it really is something completely not functional. It's kind of like a dust around the code. You see when you compile it, there is no mention about interfaces, right? Because it just doesn't. Interface is basically just kind of helper to describe stuff. It's not really anything functional.
Would that influence on, it's sort of like a filter, no? So if the user wants to input something, would that influence on their input? So if they're providing some information or data to the system, like their username and they have to put a string instead of a number, would that allow them to do it? Would that influence them or not?
It wouldn't influence them, because once you compile the code, so basically when we say compile the code, that means when you take the code, compile it, and then put it in the browser, right? So whatever goes into the browser, it's just this. It's just a pure JavaScript. So you cannot use the interfaces inside of browser to do validations or something like that.
Mm-hmm.
Yeah. This stuff, the interface, and basically pretty much anything that TypeScript does is just for developers. It's nothing to do with the end user, because eventually it will compile into just pure JavaScript, and it's just normal JavaScript. Like you would normally write this just as it is without TypeScript. So that's how it compiles. There is nothing extra that goes into browser that would help you somehow. It really is just tool for developers, TypeScript.
Okay.
I mean, that's being said. You know, I don't know what is going on in the community. Maybe they will eventually. Maybe browsers will support TypeScript, that you can just run TypeScript in the browser. If that's true, then yes, you could probably use this for validation. But for now, you cannot run TypeScript in a browser. You have to compile it into JavaScript. Yeah. So sorry. Yeah.
No, I was going to say I'm not sure I fully grasp the value. I mean, apart from like making sure like you're coding right. Maybe it's because we already kind of learned so much in such short period of time. But I'm not too sure why we're kind of learning this. But what's the point of TypeScript for us now? Maybe I'll see it later. But
I actually, funny enough, that's what I was. I didn't know how much in detail I need to go through this with you. So I asked Vasil, and he is basically just introduction, so you know that it's out there, but you're not gonna be using it. So we're not gonna delve into that. There is crazy stuff that you can do with TypeScript. So I will show you some. Let's see. So you can do basic types, you can interfaces, but then you can do literal types, for example. So you can do these kind of things where you can basically the type can be anything, like one-off basically, and there are union and intersection types which are even worse. That's a good example.
But so if we know JavaScript or the basics of JavaScript, we should be able to read TypeScript code and understand, right?
Yes, I would say yes and no. I would say, to be honest, like the TypeScript is not, it's as close to JavaScript as possible, but there are things. So if you look at this column in here, there are things like mixins and modules you may have done, namespaces, and all these kind of things where these things are very common in object-oriented programming, but we just don't use them in JavaScript. They are not in JavaScript basically. In JavaScript you just have classes, right? Like enums, for example. Like you probably wouldn't, if you would read an enum in a TypeScript, you probably wouldn't know what it actually does. Right, so it really depends on who is using the TypeScript. So there's a lot of people who will use TypeScript, and it was a very good question what you asked. There is a lot of people who will use TypeScript only for the strong typing, so they will not use any kind of advantages of TypeScript language. They will just use it for types. So literally just to add, what we did in here. So just add these kind of things, just to make themselves kind of comfortable that they know what they are doing with the types, and you're not supplying something else to the function. And also when you kind of work in a bigger team, then it does add a little bit more kind of comfort to the code, that you know exactly what you're using and how to use it. But I would almost say that these kind of projects, these kind of developers are probably let's say the worst users of the TypeScript, because they're not using anything else. And I told you we're going to talk about the init type, and now is the time, I guess. If you find a project that is using TypeScript only for types, you will find very quickly, very, very quickly, that people start using any like this, which basically says, silence the TypeScript compiler, because I want to use it just as a normal JavaScript. So what this really means is I couldn't find a good way to describe my type, or I couldn't make my function to work with just one type. So I'm just going to put any in there because I'm lazy, right? And once people start using this, then basically all the advantages of TypeScript or strong typing just go out of the window. Like there's just no point even doing it. And that's what you find in a lot of projects that use the TypeScript only for types. If there are projects obviously that use the TypeScript for other stuff, which is good. But yeah, there is a lot of TypeScript is a little bit of a kind of kind of hot word in a development. So now everybody kind of starts using it. Like I had so many projects where we started from beginning, and the whole team was kind of like, are we gonna use TypeScript? Like, are we gonna use TypeScript now? Like, why? We don't really need it unless you have a need for it. You don't really have to use it, right? Like if you're writing a specific kind of program, especially on the backend, that would benefit from strong types, then yeah, sure, use it. But like normally on the front end, especially, is it really useful? I can't really tell you that, because I haven't seen any project that would use it too well. That being said, it's very useful for libraries, right? And this is one thing where TypeScript really excels, because in general, library, when you're writing like a third-party library, or when you're using third-party library, you want to know exactly how the library works, right? You want to know exactly how it works and how it behaves, and what can you do with the library, what parameters to put into any function. So, for example, if I write a new library, so this is our new library. Well, actually, let's create a new file. We'll call it library.tx. So if I say, here we have function that will say add numbers, and it will be A and B, and it will return A plus B. Okay, so it's our function. Then we will say function greet me, or greet user, and we say name, return hello name. Actually, let's just do user, because that will probably be more obvious. And then we have another function. It's like get date. Right. So if you might have library, something like this. So you writing library, or somebody wrote a library that you want to use. So now, if I consume this library and I want to basically just call these functions to do stuff for me, it would be, you would have to go every time you call the function, and it happens all the time. Every time you call a function from library, you need to go into their documentation or look at the signature of the function and figure out what do you need to supply, right? So if I do add numbers, I mean, obviously this is quite self-explanatory, but if I say add numbers, then I need to know how many numbers can I put in there. Do I say just 1 and 2, or do I call it like this, right? 1, 2, 3, blah blah, like this. So I don't actually know if this function will take as many numbers, or maybe it will just take any amount of numbers, right? So it could take 1, 2, 3, 4, 5, like this. You can write a function that will take infinite number of parameters. So you don't actually know how to consume this function, right? We just don't know. So if we go back in here, well, actually no, let's just. So we just don't know how to consume it. So in this case, it's very good for libraries to actually create like a strong type libraries, basically. So if I say this is a number, this is a string, and this will just return a string, then if I write it like this, number. If I write it like this, then I will know when I consume the library, I will know exactly that this will take A, which is a number, and B, which is a number, and it will return a number, right? So this is that's why it's very, very useful for libraries, because you can actually tell people how to use a library without them having to go into your documentations. Now, you might ask, yeah, sorry, go for it.
No, I was going to say that's very interesting. It's a kind of is a good tool to create libraries like blueprints for your code.
Yeah, exactly. So now, with this case, you might ask, well, you should ask, is when you distribute a library, you will not be distributing TypeScript, because you need to compile it, right, for other people to use it. Because if you imagine that I have this, right? I have this library which is written in TypeScript, and then I give people TypeScript. That means that assumes that they will have TypeScript compiler to compile your library into JavaScript. Right? So you don't want to do that. You want to compile your TypeScript into JavaScript and then distribute it as a JavaScript file. But obviously, if I take now this whole thing,
you lose it. You lose all the effects.
You lose everything. So if I go now to your playground, this will be the result. So again, we don't have the types. So TypeScript thought of that, thankfully, and when you compile TypeScript into JavaScript, it will create a file that is called typings. And what it basically does is this. So this is a typing, right? This kind of format of a file. If I look at it, this is what it does. So it will create a special kind of file, which is called typing, and it will just give you the declarations of the function. So it will tell you there is a function in this library. There is a function that will take these parameters and it will return that. Without the actual body of the functions, it will just give you the kind of blueprint of the whole library, right? And these things, these typings, are widely accepted by code editors, right? So when you actually write your JavaScript code, the code editor will find that you have some typings in any of your libraries that you are using, and it will automatically give you the kind of suggestions that they would give you if you were to have a TypeScript file. Does that make sense?
Yeah, completely.
Yeah. So this is really cool usage for TypeScript is libraries. I really don't want to discourage, and I would have a lot of heat, for saying this kind of publicly, but using a TypeScript on a huge project, like a let's say that you have like a web app that has many screens and a lot of interactions and stuff like that. Using TypeScript for that, from what I've seen, was always kind of drag. It always kind of slowed you down because you try to figure out how to do the types, you try to do this and that, you kind of try to work around TypeScript just to make it work, and it was quite, it's quite a big task. And also because it's compiling, you need to always compile it and stuff and things like that. So I haven't seen it working like really well. But on a smaller projects or on a libraries like this, it's definitely useful. I can definitely see the use case in these kind of scenarios. On a big project, it's up to every developer, it's up to every project to decide if they actually want to use it or not. There is also considerations for testing, right? So if you write your files in TypeScript and then you're trying to test them, then you need to first make sure that your testing engine will first testing pipeline will first compile it into JavaScript and make sure that that JavaScript is actually acceptable for tests and so on. So there is a lot of considerations for if you should be actually using TypeScript. But I would say for developing a library that is kind of straightforward, which should be, it's definitely useful. So that's that. Ask me any questions if you would like. This is the interfaces that I was talking about. So you create interface. Think of interface. Interface is many things in different languages as well. Interfaces are not just TypeScript, they are in different languages. I would say for now, because you're probably not going to be using it anyway, just think about it as a kind of your custom type. You can just do your custom type. That is basically made out of more simple types, let's say. So you can use it with interface. This is how you install TypeScript. Any questions about TypeScript?
Not for me, thank you.
Right, so now let's talk about, we will come back to, actually let's stay with TypeScript a little bit just for now. I just want to check if they still do what I was showing you before. Do I have it still here in the code? Because that's one thing that I don't have it. That's one thing that I really didn't like about TypeScript. Let's see if it does. Right, so it doesn't seem to be doing it for timeout anymore. Let's try for promises. So, how are you doing with asynchronous programming, by the way? Do you understand promises and stuff more now? Because I remember last time it was there was some confusion about that.
Yeah, it's. I mean, for me personally, feels like you constantly need to see things, otherwise you forget. And I haven't seen that in the past. I mean, I haven't really focused on the project or exercises in the past few days. So
cool. I mean, you know, that what you said is right. I mean, even for me, like for people who are doing it a long time, you just need to kind of keep at it and keep practicing. You know, there's a lot of when you work on the projects, they will have some kind of what tools that they use and ways that they work and everything. And then when you change project or when you go to a new job or whatever, it's going to be completely different, and you will feel like you are, you know, you need to catch up again. A lot of stuff. It's just kind of continuous. It's part of our job, really.
right, yeah.
Right. So they seem not to do it anymore. I will try to come up with, if I can come up with an example that would still do it. I will send it to you on Slack. But basically, sorry.
What are you trying to do? Sorry, I didn't. Get that.
So you shouldn't be doing. You cannot. It's not syntax error, but you shouldn't be doing a. Let me actually see. Maybe it's smarter than that. You shouldn't be doing asynchronous operations in loops, right? Because otherwise you will not get the things that you expect. So let me just do a little bit. How can we do this? So if I do resolve with, or actually I know why. Let me just do console.
Why wouldn't it work? Because the promise you're creating is.
So the reason. So if I show you this, right? So and I will do. Promise.
You don't know if the promise is true or not, or it resolve or not.
Yeah, well, so you basically need to do, loop is a synchronous operation, right? And you're doing something asynchronous in it, so you cannot know at what point you get the result, let's say. Right? Doesn't make sense. So
you don't know.
Resolve reject. So set timeout.
Yeah, so you will receive like promises that are unresolved, basically.
Yeah, well, you would receive the results of the promises at different times than you would expect, let's say. So let me just show you this. So if I do set resolve, and let's do mods.
So basically, you are timing it out like random times.
Yeah. Yeah, this is going to be used. That's fine. So now we should see at least something. Actually, I don't know if you can run asynchronous stuff in here, but I think you can. So promise, and this would be this. Anyway, I will not. Yes, that's the newcomers result September. I just don't want to take too much of a time. Yeah. Right. Let me. I will make the example later, and I will send it to you over on Slack because I don't want to kill the lesson with this. So, but or if you have some time at the end. But basically, yeah. Let's do it later. Yeah.
Yep.
Cool. So, what is the next thing? Maybe they changed it anyway, and it doesn't do it anymore. What I was trying to do, but because what is the TypeScript version? Yeah, so now there's TypeScript 4. I was using TypeScript and it was still 1 point something, so it's a long time. So back to object-oriented programming, encapsulation. So why do we use classes? Some of the reasons. So encapsulation, obviously you can encapsulate your logic. Oh, actually, let's move on to the one. Abstraction, you can abstract some behaviors out. Polymorphism and inheritance. So let's continue. Encapsulation, private and public methods and properties. So the good thing about classes, and I don't know how much you touched on this on Monday, but the good thing about using classes and the encapsulation is that you can declare private members of the class, private values and private methods, and they will not be accessible from outside, right? So if you create a class and you say this is my private first name value, then you can work with that first name value inside of your class, but you cannot actually get it from outside. So let's just try that. Let's go over here. You can leave this one for now. So if you define new class, which will say user, let's say private first name, say public get username, for example, and return first name. So is that how you write it in TypeScript? I think you write a constructor like this, but I'm not sure. This first name equals maybe not. Let me just Google this TypeScript constructor. Oh, you just write constructor. Okay. That's strange. Anyway, so this is our class. So now if I create a new instance of this class, so if I say this is my user, and we will say it's a new instance of a user class. Okay. So now if I try to use the user, if you look at the autocomplete in here, if I do user dot, you will see that we have a constructor and we have the get username, but we don't have the first name, right? So this is a public, this is a private member of this class, private value of this class, and you cannot access it from outside. So even if I do console log user first name, then you will see that in errors it will say property first name is private and only accessible within the class. And if I run it, you will get an undefined. Okay, so you don't see the user in there anyway. So that's why the encapsulation is good, because sometimes you will want to have classes or scripts where you want to, think of it as an API. So you're creating a class of user, and the API, it basically means the interface of this class, what I want to see, what I want users or consumers to see from outside, is only my public stuff. The same if I do now in here public last name, which will be string, right? So now if I use this user, if I do user dot, you will see that I have last name in here now. So that's the encapsulation, that you can actually, let's say, hide some things from the outside world and just use it inside of the class. Okay, does that make sense?
Yep.
Yeah. Abstraction. Abstraction can be, I'm not sure if the abstraction is the best name for this, but basically what you can do with the classes is that you can create different levels of classes. And this is, somebody mentioned this already earlier about the master class and child class and stuff. So basically what you can do, and what I think there was a more example, yeah. So what we can do is we can say, well, we have a class of mammal, let's say, right? And then I'm not sure why it's red. And then we will have some kind of API in here. So they have breed. I don't know. Okay. Breed. And that will do console log breeding. And then you can have another class which will be, and let's say, dolphin. And you can extend the original class. And you can say eat, for example. Right. Let me see the errors. No errors. I'm not sure why this is red. That's very strange. So if I run it now, if I run it, so now I can create a instance of the mammal class, right? So if I do const, okay, let me just refresh this because it really is triggering my buttons. Oh, it's still there. Cool. So if I create a new one, and I'll say new instance of mammal, and I will have a dolphin. So what do you think is now going to be available for me in each of these classes? So if I write mammal, and if I write now dot, what do you think is going to be there?
If you write what, sorry?
If I just write dot, so I get the autocomplete of what is available in that class, what do you think I'm going to get there?
Breathe.
Yeah, what do you think, Christina?
I don't know.
What do you think is available in the mammal class? So I'm creating a new instance of the mammal class. Yeah, and this is my class. So what is available inside of the class?
The breathe method.
Yeah. Is that clear, Christina?
Mm, yeah, maybe.
Yeah, so you have a class in here, and inside of it we have the breathe method. Yeah.
Yeah.
So now, and this is not a private, we could even write it like this if we want to. Right. So now, this is our public method on here. So this is exposed. Let me actually write something in here as well. So private, let's say type. Actually, let's do name string. And then we will have private age number. Okay. So what do you think now is going to be in there if I write dot? So mammal. So this is my class. What is going to be in the autocomplete? What is going to be available in this class for me? Who wants to take it? Christina, Julio?
Well, I think definitely breathe, but I think probably name as well.
Why would you think that name would be there? I'm not saying it's wrong or not. Just try to explain why do you think it's in there.
Because you can still access this now.
Because sorry.
You can still access also the public and the private now.
No, you can the private members of classes you can access only within the class, but you cannot access them outside. So if you do any work inside of this class, so for example, if I have another function, let's say public function of print name, then I can access the name here. Right, so I can do this.name and I can access it. See, but I cannot access it outside of the class. So once I leave these two curly brackets, I cannot access it anymore because it's a private. Does it make sense?
Yeah.
Yeah. So only public members can be accessed from outside of the class. So if I write dot now, it will have just breathe. Okay. What do you think I'm going to have available if I go for the dolphin? So if I do dolphin dot, what am I going to have available now? Who wants to take that?
Eat.
Yeah, Julio?
Yeah, eat.
You're gonna have eat.
Yeah.
And breathe now.
What do you think, Julio? Are you gonna have breathe?
Yes, you could have, because you're extending the class.
Yeah, exactly.
And it's still public.
So because you're extending the class, you're extending this original class, you will have breathe. You can also override functions. So you could say, this is my own breathe. Right, so I could say breathing, right? And you can override. So this would basically override the function from the extended class from the parent class. Now, I'm not sure if they support this. No, they don't. In a lot of languages, you will actually have to write that you're overriding the class, the function. Sorry. In here, you don't have to do that. So you just basically write it there. So you're still gonna have breathe and eat, but the breathe is now coming from here because you redeclared what was in the original function, basically.
Thomas, sorry, the private, so H, for example, here, trying to understand how do you practically use it if you can only access it from the class? So if we have a practical example, like let's say you want, how does it actually work, like in practice, if you can't access it actually at all? Right.
So I think that one kind of nice example would be you can basically protect your variables, right? So I'll show you. So if you have a class of user, let's do something else, class of table, and you would have private material, which would be a string, right? And then I would do public get material. Actually, I don't think I need to even do this. Okay. Let's do this. Get material. Or actually, let me just do this. So
you create a drop down, and you can only access the material that are set in there.
Yeah, well, kind of. So let me just do return this table material. This would be just material. And then let's do constructor. And it would take material, which is a string. Oh, or I should table material. Actually, I think we can do this. Table material, can we? No. Oh, this. Yeah. So if you look at this example, what is happening in here? So we have a private variable, which is the table material. We assign that variable on the constructor. So when we create the instance of this class, and then we have this, which we call a getter. Okay, so getter basically means that you are getting a value from the class, but you can only get it. So if I now use this class, I will do const table equals new table, right? Then you see I will have an error because it will expect one argument. So we will say that this is a wooden table. So now we have a wooden table. If you look at what is actually available in the table, it is material. Notice that this material is not a function, and this is what might be a bit confusing. So table dot material. Right, so now if I execute this, you will see that I will get the root. Okay. So now what happens in here? We have this getter, and it's a function, but what really happens is that getters are just a simple values, right? Getters and setters. There are two things, getters and setters, are just a simple value. So even though we are using it just as a variable, it's actually underneath the hood is a function. You can execute logic in here before you return it. So that's getter. I would say don't worry about it too much now. But this would be one example. So for example, when you want to make sure that nobody can change the table material, so I cannot now go, like we created the wooden table, and I cannot just now go and say the material equals concrete, for example. It will not let you to change the table because you cannot assign anything to read-only property. Okay, so you cannot at this point you cannot change anything. So that will be why do you have like a private variables, because you want to protect them from the outside world, basically. That's one use case. One use case would be the protection. So you can get them or set them, vice versa, and not do the other operation. So you can protect them. The other thing would be that you just have some internal variables that are not important to the outside. So you could potentially in here you could say something like count or something like that. I don't have a good example now, but if I do this, so we have a count, which is a number, yeah, and then inside of here we could have well, actually let's do this. So this count plus plus, right? So now we will say so now what we're saying is we have this counter, how many times the material has been requested, let's say, and we will increase it internally, so we just know what to do, but we never actually expose it. And then we could have another function, and we would say public is popular, for example. and then we could just say return if count is more than 3, then if count is more than 3, right? So we can do that. So if the count is more than 3, then we consider this table as a popular. So you can see that the count is used only internally. We are adding to it in here, and we are basically making an operation in here with it, but we're not actually exposing it. We cannot change it from outside, and we cannot read it from outside. So if I do this, so we will say, we will also write this. So we will what is the material? So material is table material. Is it popular? You can say, oh sorry, table is popular. Yes or no? Right, so if I run this once, it will tell you material is wood, and is it popular? It's not popular. That's because we executed it only once. Now if I copy this line a couple of times and I execute it, you will see that the first 3 times it's not popular because the count is less than 3, and then the next 2 times it is popular. So you're basically using this count just internally to decide some kind of logic. What do you see from outside? Like, imagine that I don't know this class, the actual how it's written, and I'm just consuming it like I'm doing in here. What you can see in here is I am getting the option to call the isPopular function, right? And I don't actually know what does this class use to determine if it's popular. Under the hood is using this base.count, but it could be using any kind of set of rules if it's popular or not, right? And so it will tell you if it's popular. We don't know how it decides, and it actually decides because we're getting this value from the function. It's kind of keeping track of how many times we got the value and then deciding if it's popular or not. I don't know if this makes any sense.
Very, very clear. No, very clear. Thank you.
So really, I would say 2 main reasons would be, one, the protection of the values, so people cannot set it or get it, vice versa, and the other one would be just internal values. Again, internal values that you need to use across the class, right? If if you need internal values just within a function, then obviously just use your local, as you normally would, value equals something, right? So you can just use your internal variables in the functions if you don't need them on the overall class scope. But if you need something like we do in here, if I highlight it, we need it in different functions inside a class, then you should declare it as a private. Now, to make your life a little bit harder, there is another. So we have the private and we have the public. There is another one which is called static. What does that mean is if I say we have a static function, so static, and what could be a good example? Dimension. No, get info, let's say, something like that, right? So this is our static method, get info, and we will just say this is class to create table. This is not the best example, but anyway. So static is another keyword. Now, what this keyword means is that you can access this method without creating a new instance of this class. Okay, I know that's a little bit confusing, but you look what we do in here on the first line in this example. We create a new instance of the class table, and then we assign that instance to something. you can also in your classes you can declare static functions and variables that you can then access from outside without creating a new instance. So if you look at it now, without creating a new instance, I can say table, and if I do dot, it will give me some kind of list of stuff, and one of them is get info. Right? That's our static method that we created. If I call it, then it will give me that string that we just created. So you can have static methods. They are usually used if you have some kind of calculations or something like that doesn't necessarily need to know about the life cycle of the class, or they are sometimes even used to create its own instances. So sometimes you could have something like this. So this could actually return a new table, right? So it could return its own new table basically, which would be mirror or glass, let's say. Now you might think, why would I do this? Well, you could have something like this. Let me give you an example. So we could have static new wooden table, and it would return new table with a material of wood, and we could have new glass table. I would create a new one with glass, for example. Right? So then,
so all we're doing here is TypeScript, right?
Yeah, this is all TypeScript. Well,
right.
It's TypeScript, but this is actually in JavaScript as well.
Yeah. Okay.
So now I can say table dot new wooden table, and I don't have to say anymore that this is the material is the wood, because it has it kind of inside of it, right? And then you would get a new instance, which would have again the same API as the other one. So these things are quite useful. What I just showed you in here, they are quite useful when you don't want to have, like, for example, if we say we want to have like a set list of materials for the tables, we don't want it to be just a free kind of material, like whatever you can think of, then these ones would be quite useful, because you let the users create only. Let me just remove this. Or actually not. So you let the users create only the wooden and the glass table, instead of actually letting them to create whatever they want, right? With these kind of APIs. What you ask about the JavaScript, if you look at what it's compiled into, you can see that the static is still there, and the get is in there as well. All of this kind of stuff is still there, because this is now in ES6 basically. This wasn't in JavaScript for a long time, and then TypeScript basically did it, and then JavaScript did it as well, released it finally. So yeah, so this is still there. I don't know if you can. No. Unfortunately, it seems like you can't. Oh, there's tsconfig. Right. So this is what I was talking about. This is probably the last thing I will be able to show you. So what I was talking about, the config for TypeScript, so what it actually compiles into, this is it, right? So you have different, normally in your project, you would have a tsconfig.json file where you define it. So you would have something like this. So in your file structure, you would have something like this, and you would have target yes 2017 or something like that, and blah blah blah. So you would have this kind of config normally in your project, and the TypeScript compiler would take this and it would use it as the config for the compiling. In here on the web, they made it into a form, and these are all the options that you can use, right? So there's a lot of options that you can actually use. You can set it to how verbose it is, right? So in here you have the linters, right? So you can actually check if you want to get more errors or less errors in the console of the compiler, and so on. Now let's have a look at the target. So the target is now set to ES 2017. If we set it to 2015, let's see if it's going to be any different. I don't know if this actually changed or not. So you see that it's still the same pretty much. And if we change it to ES5, then you can see already that the classes were not there, right? So look at the difference between ES 2015, where they introduced the classes in JavaScript. It's basically the same thing like we just did in TypeScript. If you change it to ES5, where there were no classes, you can see that, you see? That's what I was trying to show you. Okay. So you can see that now there is no class table because there were no classes in JavaScript, so it wouldn't be valid JavaScript code. So now they created kind of, this is something that we call polyfill. I don't want to overwhelm you with different terms and stuff, but it's something that we call polyfill, right? And it basically means that you take something that's kind of newer and you create a polyfill, which basically means the old way to write it in case you need it for all the browsers. And this is exactly what I did in here. So what you can see that this is how people try to mimic classes and object-oriented programming in the past in JavaScript. What they did was they created a closure function. You can see this is kind of when you have like a bracket and function, that's kind of sign of a closure function. So if you look at here, this is that it starts and then it kind of closes itself. That's why it's called closure. And then it will create a function, and that function will be extended because functions at the end of the day are pretty much just objects. So the function will be extended in its own prototype. So the function prototype is an object. The prototype will be extended by all the functions or all other properties that we actually before defined. And it is even smart enough, this TypeScript compiler, that if you look at our private table material, and if you look what they did in here, this is how you can do it in pure JavaScript before this was available. You could actually say this object has a property which is called material. Oh, sorry, that's this one, the getter, right? The material, and the get function of it. So again, the getter from this object is returning this table material, and enumerable and configurable. So it's basically saying you cannot update it, right? You can only read it, but you cannot update it. Yeah, and that's the same. Going back to the original, what I was trying to show you, for some reason it's only on ES5. Look, we have a promise in our, we have a promise that does some asynchronous stuff, and in our code we execute it inside of the loop, and that's basically executing asynchronous code inside of the loop, and you can't know when you will get the results. So you might get instead of 0 to 10, or 9, you might get 0, 3, 5, 8, whatever. So the way to work around it is to create a function that takes the I parameter and then execute the function synchronously with the I in it, and then execute the promise inside of it. You would have to kind of develop into this a little bit more to understand exactly what it does. But you see how I wrote code that is not really correct. You can't really do this in JavaScript. And it compiled my code into something completely different. So it created a new function with some kind of name, and then kind of fixed my issue, basically.
Is it not doing the same thing?
It is doing the same thing, but with different results, let's say. So in here, it would make sure that you will get 0 to 10. So the console log in here, hey, would be 0 to 9. Sorry,
so the code on the right is synchronous, so it will wait until the function loop one is executed until it gets to the next one.
It's not synchronous. It's still asynchronous. But the way that you look, we taking the I and we passing it in here, and then we using it in the console. So the I is at that point in time is locked. Even though this will be executed at different times it will still be the same I that should be there basically.
So how does it change from the one on the left?
This one will just take the I directly, and doesn't have the function that will pass it into. Let's say this is not the best example. I'll try to come up with some better example, because it's not as obvious on numbers. It will be obvious on something else. Let me just come up with a better example, basically.
Oh, no worries. I'm just curious.
But this, if you want to prevent asynchronous issues in loops, basically what you need to do is you extract them into a function like they did in here, and then that's how you execute it, because then you will have like this is a synchronous operation, even though inside of it does a synchronous thing. It's a synchronous operation, basically. Yeah. So again, the tsconfig.
Sorry, can you show again that loop like on the right side?
Yeah.
Please? Just I want to take a picture. Yeah, thank you.
Yeah, so ES3 seems to be pretty much the same, but anyway, so this is the, there is even 2020, they can compile it, but we're not using anything in here. I'm actually quite curious now. So there is a new syntax in JavaScript. So for example, if I say this is my object, and name, and I do console log username, and then you can do user h, right? So this is kind of a new syntax in JavaScript. It's called optional chaining, where normally what you would have to do in JavaScript, you would have to say if user h, so if it actually exists, then log it out, right? Console log user h, just to make sure that you don't get undefined. But now there is this new syntax that you can just write it like this in one line. It's really, really useful in more complex examples. So let's see what it compiles into. So you can see that in ES 2020, it's already that specification already has this in it. So it will just leave it as it is. If I go to 2019, it still has it. No, it doesn't have it. Look. So you see, like this is what TypeScript does for you, right? So it will take whatever code you give it from the new specifications of JavaScript, and if needed by your tsconfig, it will compile it into something that is basically correct in that version of JavaScript. So this is, instead of doing that, it will check if it's null or if it's void, and if it is, then just do nothing, and if it is not, then print it out. So yeah, it's very useful. It's very useful for that kind of stuff. Right, before we go, does anybody have any question about, oh sorry, I forgot to show you polymorphism very quickly. So in classes, one thing that you can do, which is quite nice, and I think Ricardo will know this, you can write a functions with the same name, and you can do something that we call overloading. So you can say, I have one function, and I will say I have a, well, let's just for now let's just call it foo1, or let's just foo. Let's just call it, and it takes a as a string and b as a number, for example, or let's just do string for now. Yeah. So this is my function foo. I can create the function with the same name, and it will take a string, and then it can take b as a number. Right? And basically what it means in here, and this is something that you can choose to be able to do that basically in TypeScript. what it means is that I'm overloading this function with two different declarations. So I can say this declarational function will take only string, and then this declarational function will take string and a number. So what it means, when you actually start using the class, you will have one option of a full function, but they will have two different. You can use it in two different ways, basically. So that's kind of like that's one example of polymorphism, that you can actually overload functions and use them in different ways. It's very useful in a strong type languages, because sometimes you might have a function that needs to do two different things at some point, or needs to accept more inputs, and you would have like a simple version of it, and you would have more advanced version of it, for example. Yeah, so that's kind of one example of polymorphism. Right. So before we go off, anybody any questions? Anything at all?
Not for me, no, thank you.
I know it was a lot of information, but if you have any question, just ask, please.
I'm fine.
Mm-hmm.
Our heads will explode.
Yeah, I know. Look, don't think about it too much. As as we said before, you're probably not going to be using TypeScript right now. It's just good to know about it. And all these classes that we did in here, all the object-oriented programming stuff, they are not specific to TypeScript. So eventually, you will get to know them and use them a little bit more. Probably they are, again, classes are not necessarily useful for every project, so you will probably get to use them and know them better. But for TypeScript, for me, the most important thing to remember is that you can add types to your variables. So I can say that the table is accepting table material and it's a string. That's one of the most important things. So the strong type language in JavaScript. And the other important thing is the TS config, that you can convert it into whatever it needs to be, right? So if I go back to S5, instead of classes, we will have this kind of syntax. So
that's quite powerful.
Yeah, that is quite cool. Yeah. And it's been tested and proven that it doesn't yield any errors. So there was a lot of people skeptical, and actually at the beginning there were some issues where if you take bigger project and you compile it all into JavaScript, there were some issues. But now it's been so tested through time and everything that you can be pretty certain that if you have whole TypeScript project and you compile it, you change the target into something else, it will just work if there's not going to be any issues.
Who is deciding? I mean, what type of ES, like 15, ES5, ES6? Is it like a group of developer that works for Mozilla? Is like, are they paid, or is it like a?
What do you mean? Who is deciding for what? For
well, I mean, just like the JavaScript language, like how is it evolving? Like how is it like a company that owns the? I mean, I don't know.
Yeah. So the specs to the proposals to what should be in JavaScript, that's open to public. You can, if you find something really useful, you can submit it and they will consider it. There is a panel of people who are actually working on it. I think they are paid. I would assume they are paid, and they basically implementing into the language. But there is a lot of, this whole thing has a lot of process. So there is the actual programmers who implement it into language, and there are people who are just like a community, kind of they are invested in the community in the sense, maybe not even for money, but like discussing what would be best for the language, what wouldn't be best for the language, and if you kind of suggest something that is very close to something that is there already, then they will be discussing publicly. You can be part of it. Even now, you can be part of discussions. They will be discussing if it's actually worth it, or if there is just like a kind of quick workaround to do what you need. I wonder if we can do optional chaining. Yeah, look, for example, there is a proposal for optional chaining in JavaScript, and this has been written by a couple of people. This is big things, right? Like you're changing the language that millions of people are using, so it's quite formal, this whole thing. And so this has been created by a couple of people, and they will describe exactly what do they want to do. So you can see that instead of doing this, which basically checking if there is an address and then if there is a street, to get the street, you can just do this, right? So this is the proposed syntax basically, and then they describe it, and then you need to do a lot of things to describe it basically, all the different use cases that there could be, what could they return, and so on and so on and so on, and then yeah, it's really, and then you have committee discussions where you have like different discussions from the committees and stuff.
Wow.
Where they're discussing basically what if it would be a good idea or not, and this whole transcript of this and blah blah blah. So it's not it's not kind of Wild West in a sense that people can just do whatever they want or whatever. It's quite it's quite thorough process, and thankfully it's very kind of open, right? Like it's very transparent, so you can actually see what people are discussing, and you can actually chip in, right? Like if you think that something is a good idea or not.
So it's a bit like Wikipedia, but for language.
Sorry?
Oh, well, that's actually it's not. It's like Wikipedia.
Yeah, something like that, I would say. Yeah. But
we have some
proposals.
People controlling.
Yeah. So there, look, like in here, you can see all the proposals for that are at what stages they are, and so on and so on and so on. So last presented. So yeah, it definitely is a thorough process, and I don't know who actually implements it at the end. To be honest, again, like who implements it? These are proposals for the ECMAScript, right? Which is basically the how would I describe it? It's the kind of specifications of the language. Yeah. So it's a specification of the JavaScript language and what it should be in it, what it should actually do, and it's actually for web, right? And then it's up to every browser to adhere to these, right? So like if new ECMAScript is gonna include the optional chaining that we just looked at, then Google developers will have to take it and implement it. Firefox developers will have to take it and implement it, and so on and so on and so on, just to make sure that they are within the specifications, right? Because then you can. There's a very cool website. I don't know if you've probably seen it. So can I use? And this is a really cool website where you can just write anything. So if I say Boolean constructor, for example. Oh, what? Oh, Boolean constructor. Then it will tell you what browsers you can use it in, and then you can decide. Okay, Edge is supporting it since version 79. IE is not supporting it at all, right? So you need to be careful. Like, are my users on IE or not? Chrome is supporting it, and so on and so on. So you can actually see exactly when it is supported or not. So when the browser developers implementing stuff, they need to be, they need to adhere to some kind of scripts or not, and then they will show up in here. So these kind of websites, they know exactly what has been implemented in what browser, basically.
Interesting that Microsoft is all over the place with TypeScript, and actually their Internet Explorer is pretty shit.
Yeah, it is. I mean, to be honest, they did really well on the Edge. I mean, it's still not my favorite, but they basically dropped everything on IE 11 and they moved to Edge. Yeah, okay. So that's their kind of modern browser, which is based on Chrome. So that's why it's so good.
Got it. Okay.
Yeah. Yeah. So that's it. Any other questions? No? Okay, well, as always, ping me on Slack if you need to, and thank you for listening.
Thank you.
Thank you.
Have a nice evening, guys. Bye.
Bye.
Bye bye.